As the storm clouds of World War II darkened the skies over Europe, Nazi Germany's Air Ministry requested designs for a high-performance aircraft that could combine the role of ground attack fighter and heavy-duty dive bomber. In response to this request, two young Austrian aeronautical designers came up with an inventive design, the HU-136 Stubo. The HU stood for Hütter. Before the war, Ulrich and Wolfgang Hütter had applied their talent exclusively to developing gliders for sport and training purposes.
This plane is designed by Ulrich Hütter. Primarily, they designed it for themselves, to fly themselves, to build it themselves. They sold the construction plans of this plane into 21 countries.
In Germany, two well-respected glider pilots and entrepreneurs, Martin Schempp and Wolf Hurt, would manufacture the HU-17 for the Hütter brothers. Adding the Hütter glider to their plane inventory was a sound business decision, as Germany was interested in gliders for training thousands of young Luftwaffe pilots.
By now, the Third Reich had gained total control over Germany. The Nazis also harbored ambitious plans for further expansion, using a new type of warfare, blitzkrieg. The Hütter brothers were aware that the tactics of blitzkrieg employed dive bombing, so they presented the German Air Ministry with the radically different 136 Stubo dive bomber, armed with machine guns and capable of delivering two 250-kilogram bombs. At the front and sides of the armored canopy were slits, through which the pilot, like a medieval knight, could view his target as he dived to attack. Influenced by their background in building gliders, and in order to save weight, the Hütter brothers decided not to equip the 136 with an undercarriage. Instead, as with this German transport glider, the Stubo would employ a detachable dolly, used purely for takeoff and jettisoned once the aircraft was airborne. When it came to landing, the gliders relied entirely upon a retractable central skid. Although not having an undercarriage made ground handling difficult, it did achieve a considerable saving in weight. But landing the Stubo dive bomber on a skid posed a problem for the Hütter brothers. While the gliders had no propeller, their dive bomber did. The Hütter brothers solved this problem in a typically inventive way. At the end of each mission, as the Stubo approached its base, the pilot would fire explosive charges to eject the propeller blades, thus allowing the 136 to land on a skid. The fact that the Air Ministry gave the Stubo an official designation is evidence that the dive bomber's design was taken quite seriously. While its estimated speed of 330 miles an hour would have been impressive, overall the Stubo was considered too unconventional and never went into production.
At the end of the day, operational efficiency is what counts, and you cannot operate efficiently in these circumstances. For example, the aircraft after it's landed has got to be removed by tractor, probably, time-consuming. The propeller has got to be put up back on the aircraft, again very time-consuming, and all this reduces operational efficiency. If you want to have a rapid succession of flights, you are not going to obtain it with an airplane like this.
The Air Ministry had already decided on the Ju-87 Stuka, which in 1936 had seen action in Spain. The Stuka's thoroughly orthodox design made it a safe choice for a mass-produced dive bomber. The Stuka was to remain in production for almost a decade. It served in a number of different roles. Despite the Stubo's superior speed, its lack of a conventional undercarriage and limited pilot vision would not have permitted the flexibility provided by the Stuka, especially during the winters on the Eastern Front.
The cancellation of the Stubo project did not dampen the Hütter brothers' enthusiasm for aviation and design. In 1937, the same year that Wolfgang Hütter joined Schempp and Hirt as a designer, Claudius Dornier registered a patent for a fresh approach to aircraft layout. These two events would ultimately see Wolfgang working on one of the most innovative and powerful aircraft of World War II.
After the First World War, Dornier and his company became successful in flying boat production. Their advanced Wal design was flying in 1922. It became a tremendous success, selling worldwide. The Wal was powered by two engines placed back to back. This centerline thrust approach had many advantages, and the layout served Dornier well for years to come. In 1934, Dornier produced a conventional twin-engine mail plane. As preparations for war ramped up, it soon morphed into a Luftwaffe bomber, the Do-17. But Dornier was frustrated by the drag factor of the side-by-side engine layout, which he knew was less efficient than his earlier design for the Wal.
The 20s airplanes were a tad underpowered, so if you lose an engine, that's bad. By having them on the center line of the aircraft, you sort of reduce your asymmetric load, simpler. You sort of reduce the problems if you lose an engine. So a lot of flying boats had that, some transport plane had that.
Dornier went back to his patent. He envisioned a new design powered by two engines in the same fuselage, one in the front pulling, the other engine located in the middle, driving a pusher propeller via a long shaft at the rear. This tandem arrangement gave the power of two engines, but without the drag created by engine nacelles on the wings. In 1939, Dornier was working on a new high-speed bomber, and he intended to employ his patented tandem engine design.
You have one propeller pushing and one propeller tracting. Pusher propeller, tractor propeller. That's the approach that Dornier used for their Dornier 335, the Arrow.
Dornier was quite sure that this concept would not only be aesthetically pleasing, but would also deliver flight performance that would be breathtaking compared to conventionally powered aircraft. But Dornier realized that he would need to demonstrate that his revolutionary concept actually worked.
To do this, he would turn to Wolfgang Hütter, then chief designer at a test division of Schempp and Hirt. Wolfgang was tasked with developing a proof-of-concept aircraft, the Göttingen Go 9.
Wolfgang Hütter had to arrange all the details for this flying model with the Dornier company. As 1 year later, he had to do it with the Messerschmitt company when they started building the tail, side rudder, the fin and the elevator for the load-carrying glider Messerschmitt 321.
After extensive ground testing, the GO9 made its first flight early in 1940. The aft propeller allowed clean wing surfaces and a good roll rate. It also confirmed that a second engine could be placed in front of the fuselage, providing two power sources with the drag of one, and that meant a faster, more maneuverable aircraft. Just as further tests were refining his innovative design, Dornier was ordered to stop work. With the war going so well for Germany, Göring dictated that all long-range development of new aircraft be cancelled.
While Wolfgang Hütter was working on aircraft designs, his brother Ulrich continued his studies, earning his doctorate and making significant contributions to the field of wind power generation.
Uli Hütter beschäftigte sich zu dieser Zeit aber bereits mit der Auslegung von Windkraftwerken, von Windturbinen oder Windenergieanlagen. Und das ist seine Erfindung, die weltweit die Windturbinen revolutioniert hat, indem er die Erkenntnisse aus dem Segelflug, lange, schmale Flügel, umgesetzt hat in den Rotor, die bis dahin meistens kurze, breite Flügel hatten, manchmal viele, meistens viele. Und er hat gesagt, 2 oder 3 schlanke, lange Flügel bringen mehr Wirkungsgrad.
Ulrich's talents would soon be channeled back into the war effort. He joined the FGZ Research Institute in Stuttgart, where he would lead a number of advanced scientific and military research projects. Recovering pilots shot down on enemy territory was a concern for the Luftwaffe, as each day experienced airmen became harder to come by through the attrition of war. Ulrich was part of a project to attach rescue pods on the wings of aircraft which could be used to spirit away stranded pilots. Aircraft like the Me-109, Ju-87, KL-25 and Focke-Wulf 190 were tested with such pods. These aircraft might also have delivered injured troops on the front lines back to German hospitals to receive medical care. In addition to serving as ambulances, these aircraft could also be used as stealthy troop transports. A modified Messerschmitt 109 could drop a pair of soldiers or spies on a secret mission into the heart of enemy territory. As well, Ulrich experimented with attaching fuel pods to the wings of various aircraft. Like other German scientists of his era, concerned with the area rule, he attempted to find the most aerodynamically efficient design possible. While Ulrich continued his research, in 1942, Claudius Dornier submitted an updated proposal of the Do-335, the aircraft his brother Wolfgang had helped to develop. This time, the German Air Ministry gave the project the green light. Finally, in October 1943, Claudius Dornier was to see his chief test pilot take the company's crowning achievement, the Do-335 Arrow, on its first flight. The 335 was huge for a fighter, as big as many German bombers of the time. The question on onlookers' minds was how would it handle, like a bomber or a fighter?
First flew in the fall of 1943. Quite a large machine. I mean, the thing was huge. Again, it was not designed for subtlety. There's nothing subtle about a Dornier 335. It's a brutish airplane, very fast.
Weighing in at 11,500 pounds, the Arrow was a giant compared to the diminutive 1,500-pound GO-9 test aircraft, which had proved the concept. As if the Arrow wasn't big enough, the Air Ministry seriously considered marrying 2 335s together in the same Zilling configuration used with the Heinkel 111Z. The objective was to create a much-needed long-range reconnaissance aircraft, but the idea was doomed to failure. By 1944, the war was going very badly for Germany. The Russians were pressing hard from the east, and by the summer, the Western Allies had landed in France. In the air, British heavy bombers came every night, bringing terrible destruction. At first, the Luftwaffe defended with converted day fighters and bombers, but they proved no match for the RAF's composite wood-constructed Mosquitoes, which served as pathfinders, high-level bombers, and escorts. Clearly, the Luftwaffe needed night fighters designed for the purpose.
By 1942, the Luftwaffe was looking for a next generation of night fighters, the Heinkel Tu-19 would be this fearsome aircraft used against Allied bombers, well, mainly British ones.
The Heinkel Company offered one of the most advanced aircraft of the war, the HE-219, but it came late. Expensive and complicated to build, the HE-219 project was dogged by problems. The 219 could climb to 30,000 feet and intercept the RAF's Mosquitoes. But when later versions of the Mosquito could reach a ceiling of 37,000 feet, Heinkel was ordered to stop production of the HE-219.
You're looking at a very complicated machine, very expensive, powerful engines required. Do we actually need it? Can we afford it? By late 1944, the airplane had been cancelled.
Heinkel knew the 219 in its existing form was doomed. But he also knew the Air Ministry was still looking for an aircraft, for long-range reconnaissance and as a night fighter for high-altitude defense against bombers.
Heinkel believed that Wolfgang Hütter's expertise in designing gliders could be applied to modifying the 219 for this new role. So he commissioned Wolfgang to adapt the Heinkel 219 and produce an aircraft with sufficient ceiling to evade the RAF's Mosquitoes.
Und so gab es auch eine Ausschreibung für einen Langstreckenaufklärer, der in größerer Höhe fliegen kann. Und für diese Ausschreibung hat Wolfgang Hütter die Hütter 211 angeboten. Zweimotorig mit zwei Jumo 222, mit einem in Holzbauweise das ganze Flugzeug, mit einem Flügel, der in einem Stück in einer Betonpresse in Schalenbauweise verklebt worden wäre.
Because of critical material shortages, Wolfgang's brief required him to borrow components from the HE-219, as well as other already manufactured parts.
Schneller fertig zu werden, hat das RLM danach entschieden, dass Hütter nicht seinen eigenen Rumpf baut, sondern dass er den Rumpf von der Heinkel He-219 nimmt, aber den Flügel mit Motor und Fahrwerk machen muss. Hauptfahrwerk. Bugrad war ja in der He-219-Rumpf schon drin. So kam es zur Hütter 217.
To achieve a fast, high-altitude plane, Wolfgang designed an advanced wing that was much narrower and at least 20 feet longer than the one it replaced. He believed this highly efficient yet lighter wing, made of wood-plastic composite, might enable the HU-211 to reach 40,000 feet. Early in the war, the RAF had been very concerned about the threat posed by high-altitude observation aircraft of the type that Wolfgang Hütter was now planning to build. The danger of them flying over Britain unopposed was taken so seriously that a requirement was issued for an ultra-high-altitude fighter to go where Spitfires could not. The result was the Welkin. Like Wolfgang's proposed design, the Welkin employed a long, narrow wing to gain altitude. With their pressurized cockpits, the Welkins could climb even higher than the advanced Mosquitoes. 100 Welkins were ordered. In the end, only 75 were completed. Production was cancelled when it was realized that the likelihood of a serious high-altitude bomber attack on Britain had been exaggerated. Ironically, while the RAF had scores of very high-altitude flying Welkins lying idle because of a threat that never really existed, the Luftwaffe were struggling to develop a similar aircraft to counter a threat that visited them every night. With the HU-211 starting to take shape on Wolfgang Hütter's drafting board, delivery of the first two prototypes was set for February 1945.
Apart from the wing, most of the other components for the HU-211 were already in existence. The problem lay in sourcing them from different locations, as the Air Ministry had deliberately decentralized production. This tactic may have been effective in reducing damage by Allied bombing on German aircraft production, but now manufacturers were totally dependent on reliable overland transport for delivery of parts. The supply of materials to factories was being seriously impeded as roads and railways were disrupted by Allied fighter bombers, now flying from their advanced bases in France and Belgium. Against this background, the prospect of Wolfgang's born-again night fighter seeing the light of day was fast slipping away. Other German aircraft like the Heinkel 162 jet fighter, also largely made of wood, were designed and built from scratch in an incredibly short time. Over 300 of these single-engine jets were made in just a few months. They did fly and in a few instances fought. However, the 162 was small and could be built underground in tunnels and disused mines where there was no threat from Allied bombs. By contrast, the Tu-11 had now become a large plane with an 80-foot wingspan, so underground assembly was not an option. In any event, the HU-211 was never completed. In 1944, the two prototypes of Wolfgang's nocturnal Homeland Defender were destroyed in an airstrike. Ironically, there was probably no need for the HU-211, or even the HE-219 for that matter, because Dornier's tandem-engined fighter could actually reach the same altitude as the most advanced Mosquitoes, and it was just going into production as the war ended. Had the German Air Ministry accepted Dornier's proposal for a tandem-powered heavy fighter in 1942, an extremely advanced night fighter was in fact available. All that was required was the addition of radar to the two-seat trainer version, which was always contemplated. In May of 1944, the 219 was cancelled, and Hitler finally ordered the 335 into immediate production. But by then, the die was cast. The Dornier solution would come too late. Before the war, the Hütter brothers and their partners Schempp and Hirth had enviable reputations within the glider community. They were designers and pilots at the top of their game. After the war, Schempp and Hirth re-emerged as builders and innovators of extremely advanced gliders, and the company is still thriving today. As for the Hütters, they never really enjoyed the recognition they deserved during the war as they transitioned from glider to propeller power. But Ulrich Hütter did eventually master propellers, and in a very big way. After the war, his achievements in designing wind-powered generators became legendary. His airfoil-type fiberglass blades with variable pitch were light in weight and highly efficient. Ulrich's wind generators were also very reliable, achieving over 4,000 hours of operation before experiments ended in 1968. Wolfgang Hütter turned his attention back to a glider project that he had just brought to fruition at the beginning of the war. The Gauffier was a side-by-side training sailplane which for the first time allowed dual instruction for glider pilots.
Wolfgang Hütter, he designed this side-by-side two-seater, and to get the wetted surface as small as possible, they tried to make the fuselage very close, and therefore they used the space of the wing root in the fuselage for the elbows.
By 1945, the Hütters had built 120 of these trainers for the German Air Ministry. Because of its success, the Gauffier-type glider went back into production in 1951. Its aerodynamic wing roots were built by an entirely new method that is employed today for the construction of fiberglass gliders.
The fairing between the fuselage and the wing, as far as I know, for the first time ever, they used fiber-reinforced plastics to build this fairing. The very complicated shape of such a fairing, three-dimensional curves and interconnections and intersections may make very difficult to build it with wood, with plywood, or even with balsa. It's not so easy.
Though the Hütter brothers' innovative aircraft, the Stubo Hu-136, did not take flight, their passion for aviation and engineering lives on in modern-day gliders and on wind farms around the world, inspiring new generations of pilots and conservationists. The Stuka, a name that brought dread and fear to hundreds of thousands as it ushered in the Second World War. With sirens shrieking, it dived to deliver death and destruction, quickly becoming a potent symbol of blitzkrieg. Although an effective weapon of terror, the Stuka had serious design flaws. The Ju-87 Stuka had its origins in an earlier design by the Junkers company. The model K-47 was built in 1927 as a civilian aircraft at a time when Germany was prohibited from making military planes. Later it was converted to a rugged two-seat fighter with a rear gunner able to fire between its twin rudders. Over time, the K-47 developed into a prototype dive bomber. From these tests, the concept for the Stuka was to emerge. However, the Stuka was not Germany's first dive bomber. When the Nazis came to power in 1933, they quickly rearmed the Luftwaffe by transforming the Heinkel 50 and the Henschel 123 into dive bombers. The modifications to the 123 proved to be much more than just a short-term fix. This formidable biplane provided effective close support and dive bombing service across Europe until 1944. The very first Stuka produced was made in secret at the Junkers factory in Sweden. But the Stuka's introduction to service was held up by problems in development. Hermann Pohlmann, Stuka's designer, had also worked on the K-47, and he chose to adopt much of the earlier aircraft's layout, including its twin-rudder tailplane. But the Ju-87's weight and diving requirements were much greater than the K-47. On the 24th of January 1936, the prototype Stuka crashed in a dive when the entire tailplane simply broke off. The crash killed the test pilot and his engineer. The accident left Pohlmann with little choice but to modify the tail. Accurate bombing required diving vertically. The twin fins and rudders were simply too weak to withstand the strong forces during a dive. Pohlmann's solution was to change to a stronger single rudder. But this created another problem. The vertical stabilizer greatly reduced the rear gunner's field of fire. The Junkers 87 double-fin layout had failed, and the tail had already gone through one major transition, which in many ways was a step backwards, at least as far as the plane's defense was concerned. Other ideas like a rudder that could slide clear in flight were tested. This at least would have left the rear gunner with an unrestricted field of fire. The final solution came when an innovative rotating rudder was developed. However, this also meant major modifications to the fuselage. The Stuka's shortcomings forced Junkers to go back to the drawing board. This time they proposed a totally new Super Stuka with an advanced fire control system using an optical gun sight and cannons that would keep any fighter at bay. However, all this innovation would require a complete retooling of the factory and disruption of the existing production line.
Well, my feeling is that there were too many innovations involved in this aircraft, and not very effective ones. In fact, one might say there were minuses rather than pluses. To give the rear gunner a better field of fire by dropping the tail was a very small plus, because there really was an ineffective defensive situation anyway in the Stuka. Very small caliber guns with one gunner in the back. To retract the undercarriage was to remove one of the main drag factors in the dive for this aircraft. And this was a very important factor, the fact that the undercarriage did give such drag, because that did stop acceleration in the dive, and that gives you more time for aiming, better accuracy, and altogether you were removing one of the pluses and putting a minus in its place. These things have their pros and their cons, because the Stuka really, even with an open field of fire, was not very defensible. So it's a matter of weighing up pros and cons, and in this case I believe the cons outweighed the pros, frankly.
There were other considerations too. By the end of 1941, the Luftwaffe had a much stronger day fighter than the Bf 109. The new fighter was the Focke-Wulf 190. The 190 was also strong enough to accurately deliver a bomb, at least in a moderate dive. Since the new fighter now shared dive bombing duties, the Stuka had to soldier on in its original form. However, it was also given a new role where it was to excel. After Germany's abortive attack against Russia, the Eastern Front became very much a tank war. With the Henschel 129, the Luftwaffe did have a specialist anti-tank plane, but there were never enough of them. The HS-129 was heavily armored to provide good pilot protection, but the aircraft was underpowered, a factor that endangered its entire mission. So Stuka's support for the anti-tank role was timely. So the Junkers Ju-87 was pressed into service and became a very effective tank buster. Other jobs included transport missions where the venerable Stuka performed the duty of a communications vehicle, taking staff and supplies to the front line. On the return trip, it was often used to ferry wounded soldiers in a gondola set on top of each wing. In the bitter cold of a winter on the Russian front, these converted dive bombers must have been a welcome sight, although their story is little known. Equally unknown is the role that Stukas would have played had Hitler's only aircraft carrier, the Zeppelin, ever put to sea. Experienced Luftwaffe pilots had warned that if Stukas were attacked and forced to ditch in the sea, there would be serious problems. As their fixed undercarriage hit the water, the plane was likely to cartwheel. Juncker's solution was to use explosive bolts to jettison the landing gear, permitting a much safer ditching on water. The Stuka didn't just stay in service until the war ended, it also stayed in production. Over 6,500 were built before the last one was pushed off the production line, probably cobbled together from damaged or spare parts. Despite the large numbers produced, only a handful of Ju-87s have been found. But the terror they created still remains seared in the minds of survivors.
When he's diving straight at you, you see the pilot, and you are pretty sure that therefore he can see you as well, you see. And you think, oh my God, he finished me off. When he was diving at you, you had a feeling he's bound to get you. you know, and even in the First World War, people, shall we say, fighter pilots just attack and fire machine guns at people and so on. This you can hide. You can hide behind a wall, you can hide behind a ditch, you can hide behind a tree. You can't hide from a bomb, because bomb will destroy the wall. And it's really and truly frightening.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.
The Junkers Ju-52, affectionately known by those who flew her as Iron Annie, or Auntie U, or simply Auntie. The tri-motored transport, which also served as a bomber, was to become a legend, not only for her longevity, but also for her flexibility. She was in fact as much a symbol of the Luftwaffe as the Stuka and the 109.
The Ju-52 was like the DC 2 and 3, I would say an iconic aircraft because its reliability, it's three-engine aircraft, very, very reliable, and one wonders why they weren't more frequently used in the UK and the USA, the three-engine layout, because it was very common in Italy, was used quite widely in Germany, and but you just have rare cases of it in the States, like the tri-motor Ford, but it's a great solution.
The Ju-52 was constructed with the same corrugated material that the Junkers company was to rely upon for over 2 decades, going back almost to the Great War. During this period, aircraft much larger than the 52, such as the Behemoth Junker G38, also used the same cladding. However, as the 30s came to a close, Junker's corrugated hallmark was starting to look a little tired, especially compared with other foreign types like the American DC-2 and DC-3. Nevertheless, Auntie still stayed in service. The Junkers company had in fact designed a replacement for Auntie prior to the start of World War II. Although they still wanted to retain its tri-motor configuration, it was in most other respects a totally new aircraft.
The Ju-252. It was a distinct difference from the very famous Ju-52. It had smooth stressed wings and a very large cargo fuselage capacity. One of the main features about it was it had a wonderful loading ramp, which was operated hydraulically at the back end of the aeroplane. Now, this was a tail-wheel aeroplane, but after landing, the ramp could be operated and would come down and raise the aircraft's tail. And it was absolutely top-notch. And the incredible thing about it was we actually did experiments to see how this thing would react on the airplane in flight. And at the large enemy aircraft exhibition in October of 1945, we flew this aircraft with the ramp fully open, and as a gimmick, we had a chap sitting on one of the lower steps on the ramp, obviously with a harness attached, but he was sitting there pretending to smoke a cigarette. Well, it appealed very heavily to the crowds, and it was quite surprising that this aircraft had this tremendous range of central gravity and was very trimmable in that situation.
The Ju-252 had a stablemate, the Ju-352, which was made largely of wood to reduce the use of aluminum. The Ju-352 proved less successful, although they were the first transport types to use a tailgate ramp that provided a flat surface for loading. Between the two models, only 65 examples were actually produced. When Germany was attacked on two fronts in 1944, they went out of production, as the priority was more fighters to defend the fatherland. Another military transport which used a rear ramp also came from the drafting boards of Junkers. The Ju-290 evolved from the four-engine Junkers 90 airliner, which showed great promise as an advanced design just before the war. The Ju-90 airliner, like most other aircraft of the time, was a tail dragger. So when Junkers created a transport version, they employed the same lifting tailgate developed for the earlier 252. For the time, the Ju-290 transport was a large aircraft when it first came into service in August of 1942.
When I flew the Ju-290, I was very impressed with it in the sense that it had a lovely cockpit layout, a very comfortable layout. It was obviously a civil aircraft adapted to a military role, rather like the Focke-Wulf 200. It was almost similarly armed, not quite so heavily armed as the Focke-Wulf 200, but flew very nicely. And I think it would have made a comfortable, with a little adaptation, a comfortable transatlantic piston engine aircraft in the early days. In fact, after the war, of course, the Americans, they had a group, like I had, retrieving aircraft, German aircraft after the war. They were called Watson's Whizzers. And Colonel Watson actually flew the Ju-290 back to America via Bermuda. And he was very impressed with it, as indeed I was too.
It was certainly the largest land-based powered aircraft in the Luftwaffe inventory. The type was 8 foot longer than the airliner version, had more powerful engines, and a very considerable range. It had been claimed, although never proven, that it made direct flights between Germany and Japan. There was also a need for smaller transports, even smaller than Anti-U. This need was filled by the conversion of a medium-sized glider into a powered aircraft. The Gotha 244 became available in 1943, created by the simple addition of 2 small radial engines to a standard production glider. The radials were actually made in occupied France and as such had little impact on German war production. About 130 of the type were made and proved useful in moving small numbers of troops or light vehicles over short distances. Using the same glider to power plane conversion, the massive Messerschmitt 323 was another attempt to maximize the Luftwaffe's airborne assets.
The Gigant, I saw the 4-engine version and the 6-engine version of the Gigant. In fact, I taxied the 6-engine version. It wasn't airworthy, but I taxied it just as a matter of interest. It was a vast airplane, called glider, of course, and the one I captured was the D model, and it had 6 known engines, and the 4-engine one had proved difficult, inadequate number of engines, and still had to have some assisted takeoff, such as JETO, or rocket assistance on takeoff. As pure gliders towed by aircraft like the Heinkel 111Z, they were a failure, in my opinion. You had 3 Heinkel aircraft playing around with this, or the large Z, and all of them, the whole thing was a very dicey operation indeed. But once you got the 6-engine version going, it was practicable, but of course, it was a large, sluggish airplane.
Because of its great size and slow speed, the Me-323 was a sitting duck, and many were destroyed by the Allies. But when escorted by fighters, its ability to carry large loads was much valued by the Wehrmacht, especially in the mayhem that became the Eastern Front. Blohm & Voss built another remarkable transport aircraft, a long-range flying boat named the Viking. The BV-222 story is not unlike the Ju-90s. It was originally ordered as a commercial flying boat. However, as the war approached, the Viking evolved into a large military transport, which also performed some patrol duties. 6 powerful engines propelled the Viking. At first, they were fueled with gasoline, but the BV-222 was intended to be refueled at sea by submarines. Since U-boats are driven by diesel, the practical solution was to convert the Viking to diesel engines. Blohm & Voss had another prototype flying boat that was even more advanced. The BV-238 was designed to cope with harsher sea conditions than the Viking could handle. Working only with U-boats, it was expected to go on very lengthy missions. It was designed to be almost self-supporting and able to deal with many types of heavy cargo. To assist in loading the 238, it was equipped with a massive forward waterproof door in the bow. This could be employed in a similar manner to landing craft on a beachhead. What you see here is only a service hatch set within the waterproof door. To assist in handling cargo, there were derricks and winches located on the hull, making the BV-238 more like a merchant ship than an aircraft. There was also a tunnel which ran the length of both wings, providing internal access to the 6 engines, even when the flying boat was in the air. Only one BV-238 was completed. It was destroyed by Allied fighters just before the end of the war. The final example of Luftwaffe gigantism came in the form of the Junkers 390, a stretch 290 with a very capacious 110 feet long fuselage. Propelling this enormous aircraft would require 2 more engines than the Ju-290 and a much greater wing, over 160 feet in span. The extra wing length actually required an additional set of wheels on each side to support the craft as it landed. Only 2 Junkers 390s were ever built, but even these required enormous resources both in labor and material. After the war, only one of the Ju-390s was ever accounted for. This led to speculation as to what happened to the other aircraft, as the type had more range than any other German plane. When they already had a proven workhorse in the Ju-52, why did the Third Reich become so preoccupied with limited numbers of large transport aircraft? One possibility was that Germany had not prepared for a long war. The premise of Blitzkrieg was achieving quick victory by lightning attacks. the English Channel stymied blitzkrieg against Britain. With the rapid fall of France, crossing the Channel became the Wehrmacht's primary objective. This could partially be achieved by gliders, which led to large transport planes like the Gigant. Often overlooked, there was one other design that evolved in the fatherland during those turbulent years: the Arado 232, sometimes called the millipede. Just after Germany invaded Poland, the Air Ministry issued a request for a replacement for the Ju-52. It must be equipped with a rear entry ramp and would employ two of the recently developed BMW 801 radial engines. Arado designers quickly came up with a brilliant design that embraced all the latest thinking in transport aircraft. It had a rear loading ramp, but unlike most other medium-sized transports of the time, it used a tricycle undercarriage. This type of wheel arrangement would not usually work in rough terrain. However, Arado engineers solved the problem by placing a row of small rollers under each side of the fuselage. If necessary, the main gear could be adjusted to kneel the plane down. The 232 would then simply crawl over obstacles on its many rollers, which led to its nickname, the millipede.
At the end of World War II, we were, of course, interested in bringing quite a lot of heavy stuff back from Germany, like wind tunnel gear and even aeroplanes. And we were looking for cargo planes. We used a German aircraft called the Arado 232, known as the millipede because of the large number of bogey wheels that it had as part of its undercarriage layout. And this was a most effective system of operating on grass airfields, which abounded in Germany in the early stages, and where traction was very difficult to find under adverse weather conditions.
The millipede's level loading ramp made it ideal for all types of cargo. But the Arado 232 had a major problem. It came in the form of this plane, the very successful Focke-Wulf 190, known as the Butcher Bird. The 190 used the same BMW 801 radial engines envisioned for the new Arado transport. After the German failure at the Battle of Britain, there was no doubt that the new FW-90 had priority for the BMW engines. The Arado would have to look elsewhere for suitable power plants, but there were none with the same power as the BMW 801. To solve this problem, a 4-engine millipede was proposed with a larger wing. This change led to delays. The end result was that possibly the best military transport of the Second World War was limited to a production run of less than 20 examples, leaving Auntie to soldier on alone. Eventually, almost 5,000 Ju-52s were made. Many continued to fly around the world for a number of years after the war, including some with the RAF. But Auntie was not their only Luftwaffe transport. 2 Arado 232 millipedes were also flown by the Royal Air Force.
By the middle of 1944, when Allied troops began their advance into continental Europe, they started to see results of German jet aircraft development, including the Messerschmitt 262. The 262 demonstrated such a quantum leap forward in aircraft speed that existing anti-aircraft ground fire, and even other fighters, would simply have been rendered useless. As the Allies expanded their grip in Western Europe, they became increasingly aware of other German achievements in jet and rocket technology that the Allies did not have, or at least not to the same extent. And it was not only aircraft like the ME-262, the HE-162, and the Arado-234, all of which demonstrated the tremendous potential of jet power. There was also the Messerschmitt 163 rocket plane, which flew even closer to the speed of sound. If one thing appeared certain, it was that the West's existing anti-aircraft defenses were becoming obsolete to deal with new types of Axis warplanes. Even more concerning was that with extended range, another generation of jet-powered warplanes might be able to reach the US or its allies. However, if the threat of advanced military technology came from Germany, then so too might the antidote. Knowing the dreadful damage that their Luftwaffe was able to inflict on London during the Blitz, Nazi planners were quick to look for a means of protecting their own population from the inevitable RAF bomber retaliation that was bound to follow. Much of Germany's experimental defense work involved the use of rockets. At first they were powered by solid-fuel propellants. This is the Fire Lily, which was one of several such proposals. Curiously, it was anything but a defensive concept that showed German scientists their best option in defending the fatherland. Rather, it was a ballistic missile, in fact the mother of all ballistic missiles, the A-4, sometimes known as the V-2, surface-to-surface weapon. The V-2 was fueled with a combination of liquefied oxygen and alcohol. It was a fearsome weapon, against which there was no defense. Starting even as early as 1943, German scientists at Peenemünde developed a quarter-size version of the V-2 rocket into an anti-aircraft device. The project was given the name Wasserfall, and it would ultimately reach speeds of 1,400 miles an hour. Originally controlled from the ground with a manual guidance system, it later used radar and an early analog computer for homing in on its target. The Wasserfall was the world's first effective anti-aircraft ground-to-air missile, and was desperately needed by Germany, as at this stage in the war, Allied bombers were relentlessly visiting the fatherland both day and night, causing a failing Reich to look at all options. As it happened, the Wasserfall arrived just too late for actual deployment by the Wehrmacht. However, it did show the way for the next generation of Allied ground-to-air defense, the surface-to-air missile. In 1944, the U.S. War Department sought submissions from the aviation industry for an effective ground-to-air anti-aircraft missile, and eventually placed 2 sets of orders for development. The first one was placed in May of 1945 with Bell Laboratories for a short-range anti-aircraft rocket, which evolved into the Nike family of missiles. Later, in 1946, Boeing was awarded a development contract for a longer-range surface-to-air missile, which became known as the Bomark. The Boeing missile came into operation with the U.S. Air Force in December of 1959. It was to be the only long-range anti-aircraft missile deployed by the Air Force. Even as the Second World War was coming to a close, German scientists and many examples of their achievements were being transported to the U.S. White Sands Testing Ground in an isolated area of New Mexico became the new home of many V-2s, Wasserfalls, and other test vehicle research. The first successful Nike Ajax launch took place in November 1951, when a pilotless B-17 Flying Fortress was sacrificed to prove the missile's effectiveness. Nike Ajax had a top speed of over 1,000 miles an hour and a ceiling of 60,000 feet plus. The early Nikes gained their power from 2 types of fuel: a solid propellant fuel like the Fire Lily for the initial liftoff, and a combination of liquid fuels for the main motor. It was the liquid fuel that required very careful handling and time to make the first Nike missiles ready for launch. It was the time required for preparation for launch that became most problematic. Later, the much more sophisticated Nike Hercules and Zeus were totally powered with solid fuel and were capable of extremely quick deployment. For production purposes, the Nike Ajax was actually produced by Douglas Aircraft, while most of the electronic components for the ground and in the air were made by Bell Laboratories. The Army initially ordered 1,000 Nike Ajax and 60 operating bases. However, with the forming of the new United States Air Force in 1947, there came some issues of which force would be responsible for ground-to-air defense. It took some lobbying and numerous meetings to resolve that the Nike Ajax, with its original near range, was clearly to be the Army's weapon. Near range or not, the Nike was thought to have been adequate to protect American towns and industrial complexes from intruding bombers coming from what was now America's major threat, the Soviets. After the U.S. became aware of the first successful Soviet A-bomb tests, and the fact that there were Soviet bombers able to deliver such a device, the American people demanded the maximum protection for the nation. Civil defense and air raid drills became a way of life, as were empty streets and the sound of air raid sirens, all evoking a sense of fear, and the nation turned to its military for reassurance. U.S. Army Nike missile batteries spread across the country. Also, there were specialist interceptor fighter aircraft of the American Air Defense Command. Both came together to provide a front line in holding back what was perceived as communist might and aggression that was expected in the form of fleets of Soviet atomic-armed bombers. By late 1958, the Army was being equipped with the more advanced Nike Hercules, with greater power, longer range, and most of all, a single solid fuel source, providing instant readiness to defend the nation against attack. However, of equal significance was the fact that by 1959, the Air Defense Command was to have its own Bomark ground-to-air anti-aircraft missiles coming online. The fierce inter-service rivalry between the Army and the Air Force that followed posed a major problem for the Pentagon and politicians alike. What evolved was nothing short of a war of words, in the press, on television, and in the Senate. Each service berated the other's missile capability and investment of public money. The Air Force was particularly vocal in its condemnation of the Nike Hercules. However, the Army responded with an entire publicity campaign, known as Operation Truth. In the end, both systems went ahead. However, the Nike Hercules, being further in deployment, got the largest share, with 134 batteries. In many ways, the success of Nike or even Bomark could have been something of a moot point. Neither one was ever used in anger. On the 4th of October, 1957, the Soviets launched a satellite known as Sputnik 1 from a remote site in Kurdistan. The world was in awe at the achievement. Unexpectedly, the USSR had developed, built, and successfully launched the world's first orbiting satellite. And something else had happened. By placing Sputnik into orbit, the Soviets had demonstrated that they had a vehicle that could just as easily evolve into an intercontinental ballistic missile. The arrival of ICBMs on the world stage changed all the previous dynamics. There was absolutely no defense against such a device, other than the threat of an instant retaliation of the same kind. The anti-aircraft missile was never put to use simply because the long-range bomber had become redundant for strategic warfare. Nike and Bomark sites were slowly disbanded, and both East and West relied upon the threat of ICBMs in a philosophy that worked for over half a century. It was known as Mutually Assured Destruction, acronym MAD, MAD.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth, and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
The only reason for an airplane to exist is to go fast. At the Great Air Meet in Rheims, Glenn Curtis set a world's record of just over 43 miles an hour, and the quest for speed was on. In 1913, Maurice Prévost was flying a streamlined Dépôt-Dessin monoplane at 126 miles an hour, and Europe claimed the lead in aviation speed. Immediately after World War I, quest for speed became a catalyst for the development of fighter planes. Countries which had not invested in new engines for their wartime fighters would, for reasons of national pride, invest in new engines to race them peacetime. Then, in America in the 1930s, the situation reversed itself. Civilian aircraft, like the Travel Air Mystery Ship and the GB, Waddell Williams racers, became even faster than military aircraft. The reason was simple. Same engines were available to both civil racers and military fighters. The fighters had to carry guns, bombs, oxygen, and radios, while the racers were built only for speed. The world's absolute speed record was passed from country to country. And as the racers became faster and more powerful, they also became more expensive. America's Howard Hughes could afford to build his own racer, and with it set a land-plane speed record. But the absolute speed record of 440 miles an hour was set by a Macchi MC-72 seaplane in 1934, financed by the Italian government. Then military aircraft came back into the lead as the Heinkel and Messerschmitt firms competed for the title. Messerschmitt Bf-109R set a speed record of 469 miles an hour in 1939, a record that lasted for many years. When the jet aircraft came out, speed records rapidly accelerated, the British breaking 1,000 miles an hour in 1956 in a Fairey Delta II. Speeds continued to climb, finally reaching 2,193 miles an hour in 1976 by the Lockheed SR-71, alias Blackbird. While speed was the object, there were many other benefits in creating ever faster aircraft. Improvement in fuels, streamlining, lubricants, materials, and the list goes on. Speed produced not only prestige and pleasure, but also utility. The speed record setters ultimately paved the way for commercial transports, business jets, and private planes.